Hi, geometry students. If you found this video, then you got my email. Congratulations, you are in the right place. So in this video, I'm going to show you what you can do in lieu of class on Thursday. There will not be class on Thursday, on October 30th. So you are watching this video instead. Okay, as you can see, well, let me share my screen. Okay, as you can see, today you have a test due, and then tomorrow you have a project. It says plan a city, and even though it says in your Bright Thinker that it's due on the 31st, it's not actually due until November 7th. So it's going to say it's overdue all next week, but it's not actually overdue. I just wanted it to be there so you will come across it and it's in your to-do list. Okay, so we're going to go over this project in this video and get you all ready to start that. So that is a big project in our class. Just to give you an idea, going to our course settings, this project is worth 10% of your grade. It's in lieu of a final exam. You don't have a final exam this semester. We're doing this project instead, which is worth 10% of your grade. So you're going to want to do a good job on it. And so you're going to want to get started today or tomorrow. This project will probably take you about 3 hours if you're doing it correctly. But the good news is that you have an entire week to get it done. Next week, when we have class on Tuesday and Thursday, the entire class is just going to be dedicated to me helping you out on that project if you need it. Okay, we're not going to be learning anything new. All right. Okay, well, let's get started. So this project is called Plan a City, and I'm going to go into it and show you what it looks like in your Bright Thinker. You can click here to download the project, or it's attached down here. Either one will take you to the same spot. And then this display is of the rubric that I use to grade the project. So there's 1, 2, 3, 4, 5, 6, 7 different parts of the project, and then a neatness and effort category as well. Okay, so it's called Planning a City. So first of all, I'm going to show you a couple slides right now about that show cities in the United States and see if you notice anything about the streets in these cities. And I'm just going to click through these quickly. Here's Nashville. What do you notice about those streets? Boston, Chicago, and San Francisco. Maybe you noticed that many streets throughout history have been planned on a grid system. A grid is perpendicular lines that intersect. Sometimes you will see streets named like 1, 2, 3, and so on in this system. So in this project, you're going to plan a city on a grid system, and you're going to have some obstacles to work around. Just like in these cities, some of them have some rivers that they need to work around. You're going to have some obstacles as well. Okay, so let's pull open that project. You're going to want to either print the entire project, which is 1, 2, 3 pages, or you can use Kami for this project. What you cannot use is Desmos. If you give me as an image of a Desmos graph, that will not be accepted for this project. Okay, so I'm going to go over each of the steps, each of the parts of this project and explain a little bit. And again, next week when you come to class, you can ask me more detailed questions if there's something you want me to expound on. Okay, so the first and easy part is you just come up with a name for your city. And then you're going to plot these landmarks on your coordinate plane. And I've included a coordinate plane here for you. This is the one that you need to use. You're not going to use a Desmos coordinate plane. This is the one that you use. So you either print and draw on it with a pencil and rulers, or you use Kami to draw on it. I would suggest color coding some of the things that you are going to be labeling on your graph, it makes it a little more easy to read. Okay, so like for instance, the very first thing that you're going to do is locate and place these landmarks on your grid with a dot and a label. So you need a point and a label. So the courthouse is at -211. So you're going to find -211 on your graph. You're going to make a point there and you're going to label it courthouse. Make sure it's legible. Neatness is a category that you're going to be graded on. So I've seen really beautiful ones through years past where they've used Kami and they've used the text box feature to do their labels. So the writing is nice and neat. Or I've seen people print it out and use colored pencils and rulers. If you print it out, you must use a ruler. I need to see straight lines and points. Okay. So you're going to plot all those points on that graph, all on the same graph. So you're going to have several of these landmarks all plotted together on that graph. And then there's a river that runs through your city at this equation. This is an equation of a line. So the river is going to look like a line on your graph. I suggest coloring that line blue to represent your river. When you have a line on your graph, make sure it goes all the way from end to end. So let's say your river is running like this. Make sure you're graphing all the way from this edge of your graph to this edge of your graph. Okay. You also have a main highway that runs through your city, and you're going to graph it using this equation. And again, that needs to be labeled on your grid. There's only one other paved road, First Street, that currently runs from the courthouse to the electric company. So you're going to find the point where the courthouse was, find the point where the electric company was, and you're going to make a road there. Pay very close attention to that road, because if that road is not done correctly, you're going to get all of part C and D incorrect. It's based on your first street. Okay, so once you get all that done, you're going to have to fill this part out. Your city will like to attract tourists, so you'll need a tourist center at a point where the main highway and First Street intersect. Where will the tourist center be located? So you're going to find that First Street that you plotted, and you're going to find a point where it intersects with the main highway, and then you're going to write that point here. So this will be a point, an XY point. In fact, I'll annotate that on here real quick. There should be a point. Of course, you're not going to write XY. You're going to actually write what it is, but it's the place where First Street, which is going to be a line on your graph, and the main highway, which is another line on your graph, intersect. Okay, part B. You're going to plan 4 new roads that run parallel to First Street. You should pick the locations thoughtfully, planning where you think you might have traffic. Write the equations for this road. The street names don't really matter that much. I'm not really going to be looking at the names, but that is a chance for you to get creative. The equations is where I'm going to be looking. And I'm going to remind you here that roads that are parallel will have the same slope. So your slope of First Street needs to match the slope of all of these equations here. So you'll have equations in the form of y equals mx plus b. Your slope should all match your, that looks like a 0, so I'm gonna. Your slope should all match the slope that you have for First Street so that they're parallel. Then you'll have your x, and then you'll have different b's for all of them because they will be intersecting your y-axis in different places. Okay, so just a reminder, your slope for all these should be the same. They should be the same as the slope of First Street because they are parallel. So you're going to find the slope of First Street. You can do that by using your slope formula because you know the point of the courthouse, which is here, and the point of the electric company, which is here. You can use those 2 points to find the slope and then make sure that slope matches all of the slopes in this part B part of your graph. And then also make sure that your y-intercept is correct. You're going to want to plot those on your graph and make sure that they are accurate to what you have. I'm looking to see if your equations match what you're actually drawing. Then you're going to draw each of these streets on your grid. So they'll look something, and this is not completely right, but they'll look something like this. And they'll all be parallel. And then you'll be labeling them with what you decide to name them. And see, here I can see some y-intercepts. Those are the y-intercepts, and then all the slopes should be the same. Okay. All right. Going back to part C. Part C is you are establishing 5 additional roads that are perpendicular to First Street. So as we learned in class, perpendicular slopes are opposite inverses. Are opposite inverses, meaning that they are the opposite sign, positive or negative, and they are flipped fractions from the slopes you have in part B. So whatever slope you used in part B, you're going to flip it upside down and make it the opposite sign and use that same slope for each one of the equations in part C. So once you plot those with the others, you should have something that looks like this. So here's your original part B lines. And again, these aren't completely accurate. And then here's your part C lines, should be perpendicular, making that grid pattern that cities have. There will actually be 5 of them. And everybody's is going to be a little bit different. That's what's fun about this project, is that you get to choose exactly where your lines go on the y-axis. And so there's not like one correct answer. So this is similar to what a possible correct answer would be, but this is not like there's multiple correct answers. But then you would have to have the equations for all of these lines up in part C and B. Okay, part D, will you need to have any bridges on these streets? What coordinates will require a bridge? So think about where your river is, and then think about if there's streets that's crossing the river. So let's say on my grid, I have my river looks like this. Oops, hold on. Let's say my river looks like this, and then I have all these streets. I would have to go to every point where it crosses the river and write that point down for part D. Okay, and again, yours is going to look different than mine. This is just an example. All these places where your roads cross the river need to have a bridge. So you're going to have a list of points. You might have just a couple points. You might have a whole bunch depending on how your streets end up being plotted on your graph. Okay, that's part D. Part E, the fire station should be located at the midpoint between the tourist center and the electric company. Show the calculations and find its location, label it on the grid. So you're going to go back to where those points are for the tourist center and electric company, which are up here. Your tourist center is the point that you used here. So your tourist center, which is the point you're finding here, and the electric company, you're going to use those points to find the midpoint. If you need help finding a midpoint, you don't remember that formula, you can look it up, or you can ask me in class next week. Once you find that midpoint, you're going to put it on your grid and you're going to label it as the fire station. This is the most important part of it. Show your calculations. I need to see your work or you will not get credit for this. Similarly, a park is located at the midpoint between the school and historic mansion. Show the calculations to find the location, and you're going to label that on the grid as well. Okay, that's part E. Part F, the zoo is located between the post office and the school, but not at the midpoint. The ratio of its distance from the post office to the distance to the school is 1:3. Show the calculations and find its location. Label it on the grid. Okay, this one's a little trickier. I'm going to give you a little hint here, and then we can discuss it more next week. But we have, let's say we have the post office. And we have, let's see, the school. The ratio of the distance from the post office to the school is 1:3, which means there's 4 parts. I'm going to divide it up into 4 parts. So 1:3 is going to be right here because this is 1 and this is 3. So the way that you find this point here is you're going to find the midpoint of the post office and the school. And then you're going to find the midpoint of the post office and the midpoint. So you're going to find another midpoint between the post office and the midpoint, and that will give you the answer to part F. If you need a little extra help with that, we can discuss it in class. Okay, so just that one problem is an entire section of your grade. Okay, part G. The following retail locations have submitted applications to build stores in your city. Choose 4 of the following to locate in your city. You're just choosing 4 of these. And you're going to pick a location for each of these at the intersection of 2 streets. Okay, so you're going to pick 4, and then you're going to go back to your grid. And remember, you have all those lines that you drew of your streets. You're going to pick 4 places where they intersect. And this is going to be up to you to choose any 4 that you want. You're going to write those points and label, like this might be grocery store or Costco or whatever. I can't remember what they're called. But you're going to label them, and you're going to plot those points, and you're going to write the coordinates of those points here. Also, 2 restaurants will also be located in your city. What are the restaurants and where are they? So these ones you can plot anywhere. It doesn't have to be at an intersection. And but they do have a road going to it, right? Because how do you get there if there's not a road? So you're going to put 2 restaurants, any restaurants you want, and you're going to write where they are in your city. And that's everything. Okay, so I suggest breaking this up in parts, maybe doing 1 part per day since this project lasts about a week. You should be able to do 1 part per day. And make sure you start it before I see you next week so that you can know what you have questions on and what you need help with. Okay, that's everything. Thank you. Bye. See you next week.